live. Hopefully. I'm just going to wait for the live stream to catch up with me. Hello, friends. Welcome. Maybe. Offline. Am I broadcasting? Yes. Alright, oh, there we go. Okay. Weird. Weird. Oh, okay, there it is. It's just being very slow for some reason. Hi. It's been about 2 weeks since I did any streaming. Yeah, I've been doing a bunch of other stuff. Still continuing to do other things, but I do want to finish this classifier. Wow, it's been so long. So what are we doing? We are working on a project that we've been working on for quite some time. And basically what we're going to do is the same thing as the New York Times dialect quiz. If you're not familiar, it's this one. And the idea is that you answer a bunch of questions. Hi, Amir maybe? You answer a bunch of questions about this. Words, how you say things. Wow. And then the classifier runs behind the scenes and it says, you sound like you're from X part of the United States. So that's the idea of what we're doing here. And we had a problem with the label encoding for our regional data set where we were encoding the numeric answers I'd been sent by Bert Fox, thank you Bert, to the wrong text answers, which means that when the users input text, because they're taking this quiz via virtual assistant chatbot, the responses we got out were just garbage. The classifications were garbage. So the system works fine, the whole process works, and the classifier does not. So what we're doing right now is we're fixing the classifier. Sejin says the last one was Bert Primer, right? I think that was the last NLP for developers, I believe, was Shrinking Bert. Hopefully I'm gonna have one out on next Monday. Seeing how that goes. I've got faith, but I also have I'm doing a keynote for a widening NLP workshop at ACL, and I need to do that today. And that's just taken more time than I thought it would. Hi. Okay, so what have we done? We have been working on cleaning the data, and I believe we have the fully cleaned data. This is the file for cleaning the data. Oh, they do our syntax highlighting. Will they just like run R? Not like that, they won't. Okay, cool. I didn't know VS Code supported R. I'm still going to use RStudio for R stuff. Robbie, how are you today? I'm tired. Hi, Christian from Honduras, a fan of Rachel's live coding on Kaggle. Aw, thank you. It's good to have you joining today. What are we doing? So we have this data cleaned correct. And what is in this is, it's missing something important. Beans. So we have the user ID and then the answers to their different questions. These are questions that we hand selected a while ago that would work well for a typed text input assistant. So we removed a lot of the pronunciation questions mostly. But what we don't have here is where these people are from. And since that's the thing that we're trying to predict, we're going to want that information. So I don't think we're actually quite done with our data prep. I should have RStudio open somewhere. There we go. I'll move myself up here. There we go. Right, so here's the data cleaning that we've done so far. And let's just quickly go through that. So we read in the raw responses. And actually, let me double check the raw responses real quick, because it is possible that I think I just want a summary, actually. It is possible that the raw responses don't have the location information in it, and hence we're going to need to merge it in from another data file. Yeah, for sure it does not. Okay, so far we have the user ID, but not where the user is from. So presumably something else in this raw survey dialect survey data in here. Users, maybe? Oh. Interesting. Interesting. Okay. So, the original data set that we used, the things that we were classifying things into were city, the information we had for the first classifier we built was city, state, and zip code. What we have here is not that. We have latitude and longitude. And if you have seen, let me just quickly pull up one of these maps in another tab so you can see what I'm talking about. Times dialect quiz map. What we have when you go through, this is just somebody's example. When you go through the New York Times dialect quiz, you get an output like this. It's a heat map that's a map. It's a heat map. So it's a map of a physical location. And the redder part, so for this person looks like New York State, basically, are the places you're more likely to be from, and the bluer parts, the places you're less likely to be from. So this person is for sure not from, Kentucky, West Virginia, or Ohio. Pretty sure that one's Ohio. There's a lot of states. And then you also get the top 3 cities. And what we don't have in this data set, so the most recent version we've been sent, is the cities. Huh. Okay, so a couple things I could do here. So one thing is that I could treat this as, basically treat it just like 2 dimensions in space and map people onto dimensions, and then do some sort of lookup to find out what city is in the area of highest density. And then we could show the person the map. Eventually I do want this to be a voice assistant though, and unfortunately you can't show people maps real good through a vocal medium. So that might be a little bit of a problem. Other things that we could do is that right now I could code this into city. So I could look up the closest city for each of these points. And that could potentially give us something to classify into. Yeah, so my biggest problem with using this is just like dimensions on a map and classifying into like spaces in a map and basically building this sort of heat map is I don't know that much about geospatial stuff. Like I know a little bit about geospatial stuff, like I know a little bit about like polygons, and I know that like you usually have to like pay for APIs to get the shapes. Yeah. Cupwork says, how are you? I'm struggling with getting the diet classifier or CRF entity extractor to extract the elements of a list slot in one go. I read the doc in Rasa forums, but I can't work it out. Take it from the elements of a list slot. I would probably post about that on the forums, Cupwork. It would take me a bit of digging to try to figure that out. So, And I don't have a lot of information about how the folks behind the New York Times dialect quiz originally did things. And there's some speculation online that they were doing clustering, or just like k-nearest neighbors, so very straightforward. And presumably using this longitude, latitude data, because that's sort of what the map that you show to users suggests. And then I'm guessing doing city lookup based on that. Yeah. The big problem... Oh, I guess it's not a problem if you're doing k-nearest neighbors. So it's like if you're trying to classify... If you're trying to do sort of multi-label classification, one for the latitude and one for the longitude, that introduces some additional wrinkles. But if you're treating it as a two-dimensional space, because it is, then you have... you can just use that, especially for something that's spatially based. You can probably do an SVM as well. I think the benefit of doing k-nearest neighbors here is that tends to be fairly fast, especially if you already have the dimensions established. Big problems. Population density in the United States is not uniform, so I'm guessing also that our well, you know what? We can absolutely do this. So let's encode responses, recoding factor levels. Yeah, so let's do this right here. So add participant location in. So we're gonna want to read in users equals CSV user. Oh, right, because we're in a new what was this called? Raw. There we go. Raw dialect survey users.text. Yep, rad CSV is nothing. It should be read CSV. All right, and then I want to plot users. Okay, so also we need to handle this somehow. And I think, can I just copy this here? Paste, select all. Yeah, so the header of this suggests multiple columns, more than 3 rather. So parents, native speaker, gender, year, native speaker. This is probably birth year. This is probably whether or not they're a native speaker. And that information isn't included, just these columns, lat and long. So what I'm going to do is I'm going to read, but I'm going to skip the header. Amar says, were the original survey working well in your opinion? Were the results sort of satisfactory? So the original survey wasn't run by me. It was known as the Harvard Dialect Survey. So a bunch of students at Harvard filled out the dialect survey as part of a dialectology class, and then it sort of grew and was administered online, and it's a little bit old at this point. I think it was run in 2003, I want to say, so we're coming up on that being 20-year-old data. Wow. A little bit out of date probably, but still fairly useful, I think, for this type of thing, and it's a fairly large data set. So we have about 45,000 results, as I remember. Yeah, 47,000. Some of those we're probably going to have to drop because of incompleteness. Oh, right. Read underscore CSV Reader, which is the library that is from. Skip first row. So the first row is the header, and it suggests a different number of columns than we actually have. I'm assuming the data was redacted for privacy reasons. All right, and the argument for that is skip equals, nope. Yeah, okay, so now we will, there we go. Skip 1, and then I'm also going to say header equals false so that it doesn't treat the first. So it doesn't treat the, oh no, it doesn't have one. I was going to say so it doesn't treat the first row as a as the header. All right, so it looks like header equals false is not available in the reader version. And then I'm going to convert this to a tibble. There you go. So a tibble is just a, oh, excuse me, as underscore tibble. So a tibble is just a variation of our data frames developed as part of the Tidyverse by Hadley Wickham, and I think Jim Hester maybe worked on tibbles, a bunch of different folks. And it solves some of the problems that data tables have that is around mostly like memory management and some potential ambiguities with data types. All right, now if we look at the head of users, nope. That's not it either. Okay, yeah, so you can see that it definitely was just like, just removed content from the end. Is this from the tibblizing? Is that what's causing these problems? No, okay. Jiminy Cricket, okay. So I think I need to specify manually that it's tab delimited, and I believe that as Tibble will do that automatically. Is that backwards? No. I'm fairly sure that read CSV has a delim function. Read.csv. Actually, you know what? I can pull up the help in here so you can follow along a little bit easier. Yes, I can see how that would be. That's nothing. There we go. All right. It's a little bit small, but you should be able to see header equals false. Quote. So I want to specify what the character is that's delimiting it. And I could have sworn it was delim, but I guess not, huh? Sep. Sorry, it is SEP for separator. Set values must be 1 byte. All right, and now if we look at head of users, hopefully it's not gonna be something that makes me sad. Yeah, nice, all right. So from here, I'm going to drop V4, is that an uppercase or lowercase v? I think that's a lowercase v through V7. Nope, you can't slice like that. Oh wait, is it because this is an uppercase V? Nope. All right. I think that might be the pandas thing. All right. Drop columns R. Pandas data frame, not what I'm looking for. Oh, actually, one sec. I can use a slice. I just have to slice by index. So in R, we index from 1. So 1, 2, 3, 4, 5, 6, 7. So we're doing, oh. Duh. Unused argument. Is drop not the name of this? Let me double check. Oh, right. You have to select by negative index. And I believe it requires a vector. Will it let me slice by heads? Maybe. Column V4 doesn't exist. You sure about that? I think the column V4 does exist, unless that's a capital V. Is that my problem? All right, now let's look at the head of users. How have I doing? Oh, all right, and now we're just gonna have to rename it. So the first one is x-axis, y-axis. And the x-axis is the longitude, because the latitude is like the rungs of a ladder, is what I remember from grade school a very long time ago. And we'll see if this makes a useful, useful map. And also, it's plot, like just the English word plot. And yeah, all right. Yeah, I think that works. So this is recognizably, well, at least recognizably to me, sort of the shape of the United States. You can see there's Texas, there's Florida, there's Maine, sort of like the dip for the Great Lake. I think that's Michigan, maybe, is the lake that's there, or Superior. I don't know the Great Lakes part. Okay, yeah, so I guess we're just gonna use latitude and longitude and treat it as a k-nearest neighbors clustering problem and see how we do. And then for reporting the results back to so reporting the results back, we'll get, what will the output of that be? It'll be a latitude and longitude, right? And then we can just report the closest city to there, I think. I think that makes sense. Yeah, okay. Now what we need to do is, first we got information about the users, and then we want to add their participants. And at this point, is it decoded df that we write out? Yes. And at this point, let's just really quickly check out decoded, coded, which may not exist because I don't think I've run everything here. Yeah, I know. All right, so let's just quickly check out decoded. Yep. All right, yes, that looks as I expect. And what I want to do now is I want to merge. I want to merge my users data set that has information on the latitude and longitude and my data set that has information on the words that they say. So what I'm going to do is decoded df, and then I'm going to merge with users. User ID is what we've called it in the data frame, and in users it is called ID. So I'm going to rename ID to ID, and I'm going to do that by using mutate, where user, what was it? User underscore ID equals ID. Nope. And then I'm going to remove the column ID. So now we should have, if we look at users, the column with user ID called user ID rather than ID. And it sure is. And it's in a different place, and that's fine, because we created a new column and deleted the old one. And then we want to merge the decoded data frame with users by, it may actually have to be full join, but we'll cross that bridge when we get to it. Actually, I'm just going to quickly look at merge. 2 data frames, column, row, or name, blah, 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 blah. Oh, I may not even have to do anything. It might just sort of work. Let's see it. Omitted rows. that long. All right, nice. One of those things where it just sort of works. I love specialized languages because sometimes they just kind of work. Fantastic. All right, so now we have the latitude and longitude as well as information on what the users are saying, and then I'm going to make sure that first of all I'm not taking the structure, I just have the data that I want, and then I got to find out where I was first. Decoded. Add participant's location in, there we go. And then I'm going to, instead of just sort of doing this and then discarding it immediately, I'm going to save it back to that data set, and I'm going to run everything top to bottom for reproducibility. And then 16 by 23 is our output. So dialect cleaned correct, and you can see, so we've wrote out our CSV and then we read it back in. This is the one that we've read back in, and as you can see, it's got the user ID, it's got all these words, and also has the latitude and longitude. So we are good to go. And at this point, I think we can start working on our classifier. Robbie, sorry, I was really focused there. Importing data sets. The option in RStudio. Yeah, I could do that. I want to, as much as possible, I prefer to keep things scripted because it's just easier to rerun later on. And this is already the second time I've had to go through and redo stuff with this data set, and I anticipate more in the future. What is better, cloud computing or Kaggle? So Kaggle is cloud computing. If you use a laptop in private, it's called, in a private jet, it's called cloud computing. Yeah, so Kaggle notebooks, at least as far as I'm aware, still run on GCP, which is a cloud provider. And the big difference is that instead of running it on, you know, a piece of hardware that you own, like a laptop, and running it locally, you are sending data off and making requests to a server somewhere else. And that's, I forget who said cloud computing just means other people's computers, but that is the case. All right, so at this point, I think we're ready to hop back to VS Code. And I'm going to move me. Woohoo! There we go. And at this point, if we pop this open again, we should see that we have latitude and longitude at the end. And for sure we do. Excellent. So now we have all the information we need to build a classifier that will classify things into latitude and longitude. And I am afraid we're going to have to throw out all of the other work that we did. So when we did the original, it's a Jupyter, it's not that. Data visualization, ain't that. Label encoding, joblib. Am I completely missing it? Data visualization, classify. Oh, here we go. So here's where we built the, give that a moment to launch. So this is where we built the original classifier. And because our classes are entirely different, I'm afraid we're just going to have to throw this whole thing out. I don't think we're going to be able to use any of this, which is, you know, a little bit frustrating, but we'll make it work. Oh, sorry, Additional, but I just noticed that you said as_Tibble from like half an hour ago. Sorry about that. I think I'm running at about like 80% of normal right now. What's normal? I'm just having a little bit more trouble focusing than I would in different times. So, as you can see, maybe, well, it's big enough you can probably see, we were working with city and state combinations. We no longer have that information. We can get that information, but I think it makes sense to do that once at the end, right? Okay, so let's, okay, I'm just gonna quickly talk through the pros and cons of two different approaches. So one approach is to get all of the latitude and longitude and convert them into the nearest city now. big problems with that. I mean, a big one is that you're going to create artificial sparsity because you'll be moving things from rural areas into cities. So just as an example, the city that my family's farm is technically closest to does not have a zip code any longer, so it's no longer recognized as a city, basically. So you would, instead of moving it to sort of like the closest population density, I don't know, it's like 10 people, you'd be moving it further away. So there's more possibility of perturbation there, especially for rural communities. That said, the US is a highly urbanized country. Most people live in cities, so it may not be that big of a deal. So possibility of introducing data distortion by converting to cities. And also, converting to cities, you're going to have a lot of classes. So what we ended up doing the first time is we used that city-state combination, and then we removed classes that were particularly rare. So I think any that did not occur at least like 5-7 times. It's in here somewhere. I don't feel like scrolling. So you're going to end up with a massively multi-class classification problem. So that's one half. That's one option, is to do the converting from numbers to words, basically, now. The other option would be to have the classifier return latitude and longitude, or I suppose the most likely latitude and longitude, and then in the assistant, convert that into a city. So the way that would work is we already have an action server running, so it's serving the classifier, and we would need to add functionality to the action server to basically make an API call to look up what city is closest to the latitude and longitude that we had identified as being the most probable that the person was from. For that, we're going to have to use like a maps API. I know, there might be a free version. If there is a free way to do it. If there is a free way to do it, it's almost certainly going to involve a lot of map data, like a lot of geospatial data. If there isn't, because I know a lot of map APIs are like, you gotta pay. Like Google Maps API used to be free for like a certain number of requests, and it is no longer free. I guess I could just, because eventually I'm going to need to set up cloud hosting for my assistant anyway. I could just use it on the same cloud provider and have sort of like one continuous work through that way. Making API requests means we're going to have to handle credentialing. I'm going to have to create credentials for this project, which I can probably do, but I'm going to have to do offline so I don't accidentally, reveal secret keys. So I think in terms of technical ease and making the project like very modular and not have a lot of dependencies, the easier thing is going to be to convert these latitudes and longitudes to cities now. However, in terms of accurate classifications and doing a good job on the problem, I think the better option is to return latitude and longitude and then do lookup at time, like at when the user is using the assistant. Big problem there. We're going to have a little bit of extra lag because there'll be lag when we run the classifier, and depending on how big the classifier is, it might take a couple hundred milliseconds. Probably not that long. Because it's not that many features. So I'm not super worried about that, but then the lookup might be another little bit of lag. But you're only doing that once per interaction, so maybe not such a big deal, especially if we tell people that we're working on it. And as I remember, there is a little bit of a lag in the New York Times dialect quiz as well. So yeah, I think for now we're just going to work with latitude and longitude. And I'm just going to quickly look up something about like mapping in Python, because most of the geospatial stuff I've done in R. I've done a tiny bit in Python, but not a whole bunch. So I think it would be worthwhile to, what do you call it? So there's a specific word or phrase for when you use latitude and longitude to look something up. I think it just might be lookup. Look up city closest city, lat, long, Python. Getting latitude and longitude coordinates for a long list. Okay, here's something from Reddit. I'll pull this over. How to get city country from latitude and longitude offline, which would be ideal from my point of view, because then we can just do it in our action server and we don't have to introduce a bunch of dependencies and connections. I need to get country and closest city from latitude and longitude. Geocoding. That's what it is. Geocoding and reverse geocoding. I knew there was a word, and I knew that I'd heard it, and I knew that I'd forgotten it. So there's this library, reverse geocode, only works with Python 2, which we do not use. Database of city, country, lat, long. I don't want to do that. That seems like a big data dependency. Reverse geocoder. Let's see. Latitude, longitude coordinates returns nearest town city. The library improves on an existing library called Reverse Geocode developed by Richard Penman in the following ways. Besides city and country, this library also returns the administrative 1 and 2 regions. Performance is much faster since a parallelized KD tree is implemented. Supports Python 2 and 3. You can load a custom data source. Okay. This looks... Is this offline? Yeah, and this is by AJ Thumpy, maybe? All right, so I think we have a solution. And if this works offline, then I think we're going to be good to go and our problems are solved, thanks to the power of open source. Robbie says, did you try SF package? Maybe at some point. Offline reverse geocoding. Yeah. All right, and this was last updated a couple years ago, so there might be some growing pains. We might run into some bugs and have to file some issues. But you know what? I'm willing to give it a shot. All right, so I think that is. We can actually get rid of this. I think that is. Pretty much an answer to our problems. So since we can do offline reverse geocoding, I am absolutely happy with returning latitude and longitude then. Okay, so let's create a new ipython notebook. Let's call this lat long classifier.ipynb. What if you started the Jupyter server, huh? And I'm gonna give myself some little notes on what I'm planning to do. My approach. And we may not be able to get all the way, I mean, we're definitely not gonna be able to get all the way through this today, but I think it is always a good idea to spend some time really talking through what you're planning to do and making sure that it makes sense and considering alternative options. And if you were working in a company and wanted to get promoted, you should have that conversation in a document. little pro tip. I guess it depends on the company, but that's usually like a good evidence of impact. And technical maturity. All right, so take in, what would you call that? Word answers? User text input, return lat and long, convert lat and long to closest city using and it is reverse geocoder and not reverse geocode because the latter is, as I remember, only available in Python 2. Okay, so this is what we're going to do at inference time. retraining. So what do I have to do? So first I have to encode labels. Do I need to encode? I suppose it depends what sort of thing I'm doing. Because if I'm doing some sort of hierarchical model or some sort of tree structure, I don't necessarily need to encode first. So I'm going to put a question mark there. I may not need to. Encode labels and save encoder. I don't need to save the encoder if I don't have an encoder. Train classifier. Latitude and longitude. Oh, also clearing. If you all remember when we mapped our things, there were definitely some points that were not inside the US. So remove points outside the US. But we can't just go through and like chop off at the borders because we need to make sure that we are including Alaska and Hawaii. How are we going to deal with like Puerto Rico and like all the places the US did a colonialism but didn't turn them into states? I'm just going to say remove points outside the US. I think that's going to be the clearest way to say that. And whether or not we remove missing is going to, if needed by classifier, remove missing. Because some algorithms can handle missing data and some cannot. All right, so I think that makes sense as sort of a general approach. And I'm just gonna do like a quick search because again, I don't work with geospatial data a whole lot. It's not really my forte. I work with text data more. You'll be surprised to learn. Mostly I do NLP. And I bet someone has already done this, right? Someone's already created the code that we need for this. So, what's a good search term for this? Classifier, latitude, longitude. Latitude and longitude finder on map, get coordinates, nearest neighbors. Yeah, I think that's what I want to do. I think I want to use a nearest neighbors approach. So from Stack Overflow. All right, how to find the nearest neighbors for latitude and longitude. Point on Python. That's what I'm looking for. Can I use a KD tree for quickest nearest neighbors lookups with points, latitude, and longitude? Is it necessary to transform the geographical coordinates into coordinates XY? I mean, they're already XY, so my answer to that would be no. Is this the best way to solve it? I don't know if using a KD tree would work correctly, but my hunch says it would be inaccurate. I think you'd want to use something like a greater circle distance to get accurate distances. Distance haversine. Right, because the problem with maps is that the Earth is not flat. And all of our sort of two-dimensional plots assume flatness. So you're going to have to do some sort of transform. Okay, so that's what they meant about X and Y. Gotcha. All right, where to find the validate points? I think you're trying to solve the K nearest neighbor. Since your data is in 2D, KD tree will work nicely in general. If your port started living in a higher dimension, a KD tree would not be a smart choice. Okay, good to know, because we are in a higher dimension, because our input vector is going to be all of the... Yes, it is. So we're looking for the nearest neighbor, and we only care about the latitude and longitude of the output, but we're going to have to find the nearest neighbor for all of the input, which, except for the user ID, obviously. Hopefully obvious. We can just get rid of that. Actually, we probably could have dropped that already. So we care about a pretty large dimension, I think like 29 dimensions, because we've got, 27 questions, and then latitude and longitude. Points in latitude and longitude cannot be converted accurately into 2D coordinates. Okay. Scikit-learn provides the ball tree class that supports the Haberstein metric. Totally Not a Bot says, hi, how's it going? It's going okay. What's the goal of this project? So the eventual goal of this project is to have somebody answer a bunch of questions about the different ways that they say things. So like, what would you call a sugary carbonated beverage? Would you call that soda or Coke or pop or, I don't know, phosphor or whatever you call it? And then reply, once you've answered all those questions, with where in the United States language usage most closely patterns with your language usage based on your answer to those questions. And we actually have the assistant built to do all of the other things. But the problem is that the first classifier that we built gave garbage answers. It was not very helpful. So we're rebuilding the classifier. The first classifier had as its target city-state. So like New Orleans, Louisiana, or New York, or Los Angeles, California. And instead, now we have coordinates, so latitude and longitude. And we're trying to figure out a way to guess latitude and longitude based on a large number of coordinates. Amir says, do you have an idea for merging the k nearest points? Yeah, so what I mentioned earlier, one way to do this would be to take the points and convert them into the nearest city. The problem with that is that you're going to introduce some artificial sparsity. So rural areas are going to get converted to their nearest city geographically, and not necessarily the city that has the greatest linguistic weight, if that makes sense. So I want to also weight by population before I convert my latitude and longitude into okay, let me put it in a different way. So I live in Seattle. Across the water is Bellevue. If you live in a houseboat in the lake, and you are slightly close to Bellevue, I might assign you to being to Bellevue. But there's more people in Seattle, so I think I prefer to assign that point to Seattle instead of Bellevue. And if I'm doing a k nearest neighbors and we have more samples from Seattle, which would seem likely because of the population density, assuming that we have a good sample, our sample should reflect the population density of the different cities, then I should be able to handle that with k nearest neighbors without manually converting coordinates to cities beforehand. Also, that sort of reverse geocoding is just going to take a really long time, and we have like 47,000 points, and I don't want to. That's just a lot of lookup. Yeah, Amir says, so if we have the 5 nearest samples with their latitude and longitude, we estimate a latitude and longitude for the current point, so we just do max voting for all the cities. Oh, I see what you mean. Okay, so you're doing k nearest neighbors without latitude and longitude. You're doing k nearest neighbors on just the linguistic data. And then once you've identified the k nearest neighbors, you use their location to find the location of the supposed location of the next dot. Yeah. I guess the biggest problem with that, so if you have features that are associated with, say, some sort of population diaspora, there's been a couple in the United States. A lot of Black folks moved north after the Civil War, for example. Then if I am like, okay, you sound a lot like you're from, let's say, Miami, and you sound a lot like you're from LA, and you sound a lot like you're from Austin, maybe. And then we do that sort of majority votes, then we would say that you're from Louisiana. We've identified you as being from New Orleans. I think that's what would be sort of between those points. Actually, it would probably be somewhere in the Gulf of Mexico. We've identified you as being from the Gulf of Mexico. I don't know how common that's going to be, though. And these features, each of these features should be pretty discriminative geographically. So it may not be a problem. Let me take a note on that. That is definitely one approach. Let's start a new section, make that markdown. Canon on non-geo features. Majority vote for and then that was so that's one option. Classify into locations, maybe? I may have to ask a friend that actually has any geospatial background what they would do. Classify the locations of digestion. That's not what I'm looking for. Classify into latitude and longitude. Classifying latitude and longitude into suburbs. So then you have latitude and longitude and you want to know the class. That's not what I'm looking for. What is UTM? Universal Transverse Mercator Coordinate System. Okay. The Universal Transverse Mercator Coordinate System is basically a geographical latitude-longitude system that is expressed in a two-dimensional projection of the surface of Earth, where the Earth map is divided into 60 zones, each which of them is separated by 6 degrees on longitude, and the locations are expressed in terms of the so-called easting and northing. The system is most commonly used for military purposes. World Geodetic System, WG S84 standard. I had hope for a second that these zones would actually be useful. I had hoped for a second that those zones would be more like good target classifiers. I think I need to think on this. I think I need to take some time and read more up on geospatial stuff and make sure that I'm making a good choice and not a bad choice. Because last time we built a classifier, we spent a lot of time on it. We did some like hypothesis testing. We tried different types of classifiers, and we ended up with something unusably bad, I would say. If I remember correctly, our accuracy was somewhere around 5%. Like we were right 5% of the time, which seems a little low. And that was 5% in the top 3. So maybe not the best choice. And I don't want to spend a bunch of time working on something and then find that, you know, everyone in geospatial analysis is like, oh, what? That's a simple Fraser transform with, I don't know, kerning or whatever. I don't know any geospatial. No, that's not fair. I don't know enough geospatial to be able to know what the easy answer to this is. So I think I'm going to call this here. Also, my voice is starting to go and I have to give another talk today, so it's about what I got. And do some thinking, do some research. If any of y'all come up with